Hello, this video is intended to help you get 100% on the Unit 2 chemistry test. One of the things we looked at, of course, was significant digits. And remember, the reason for significant digits is so you can look at a measurement and decide something about the precision of the instrument that was used to make the measurement. So in this particular case, in fact, in most of these cases, the thing that's difficult to determine is if the zeros are significant or not. This 1 and 2, of course, are significant, but the zeros are not. So why are these zeros not significant digits? Well, our rule is that to be significant, a zero must be either trapped between other significant digits or be the final zero at the end of a number after a decimal. So a final zero after a decimal. So if we look at this 0 right here, it is the final zero after a decimal. And so in letter C, the significant digits are these 4. Or in this particular problem, the zeros are not final zeros, so there's only 2 significant digits. Or here, this 0 is a final zero after a decimal. These 2 zeros are trapped between significant digits or sandwiched between them, so all 4 of these are significant digits. And here these zeros are trapped between significant digits, so they are significant digits. Now up here, of course, in the scientific notation, anything we write down here is scientific notation. The 12 written up here is those are just zeros that are placeholders. So ask yourself, can I look at a number and tell how many significant digits there are? Next question is, can I look at a series of measurements that I'm adding and tell how many digits there should be? Now in this particular case, the least significant number of these is the 12,000. In other words, 12,000 could be a number, it could be a measurement of something between 11,500 and 12,500, somewhere in that range, because it would have to be greater than 12,500 in order to round that up to 13,000. So even though we're adding these numbers here, it doesn't increase our final answer high enough to get it higher than the 12,000. So we don't include any digits past the least significant digit. Now that's for addition and subtraction. But if you're multiplying or dividing, the rule is a little different. We look for the number, in our measurements, how many significant digits do we have? Well, in this measurement, we have 5. Someone may look at this and go, well, here we only have 1 significant digit. But remember, these are definitions of 1 meter and 100 centimeters. And really, 1 meter is just considered to be exactly 1 meter. And so it has an unlimited number of significant digits. And it's true that no matter what portion of a meter you have, there's always 100 centimeters, exactly 100 centimeters in 1 meter. So those digits are really unlimited. So our original measurement here, 5 significant digits, we should round our final answer to 5 significant digits. Number 3 is really about base units in the International System of Measurement. So in class, we're going to be using grams, even though the base unit for mass is the kilogram, the only base unit with a prefix on the front. B, when using a thermometer to measure temperature in class, we will be using, of course, and have been using degrees Celsius. Even though the base unit for temperature is not degrees Celsius, it is Kelvin. Kelvin is based on the temperature scale that has no negative temperatures. Absolute zero is as cold as it gets. Letter C, when measuring the base unit of time, you might use seconds, but of course you need to be able to convert that to hours and minutes, and that hasn't been a problem for most of you. And of course, when describing how many particles are involved in a chemical process, you need to think of the mole. Now, if you're traveling from Vancouver, British Columbia to Toronto, Ontario, you would probably measure that in kilometers because it's a fairly long distance. You would use kilometers even though the base unit for distance is a meter. In number 4, you're looking at some of the conversion factors you might need to know for the test. So there you go, some conversion factors you need to know. There we go. Pause and look at those if you need to. Conversion factors like kilo going to kilometers to meters. One big thing has a lot of little things is the way I normally write it. So 1 kilometer is 1,000 meters. Now, milli, as in 1/1000th, there are 1,000 of these little milliseconds in 1 second. And for micro, that's this prefix right here, micromole, it's 1/millionth of a mole, so there are a million of them in 1 mole. In number 5, we're looking at that skill you practiced in lab to use all the certain digits and then make an estimate within that gap to measure the uncertainty, that one last digit that to get the significant digits. Remember, significant digits are all the certain digits plus one uncertain digit. So in this particular case, we can see that that's a little more than 4.3, probably not quite 4.4, just a little under that. So 4.34 to 4.39, those kind of estimates would be appropriate. Or here we see that this measurement is a little less than 4.5. We can tell it's 4, a little more than 4, a little less than 5, a little closer to 4, so probably 4.3 to 4.4 would be a good estimate there in number 5. What have we got going on in number 6? In number 6, we have the first one of these problems that, of course, will be graded on a 5-point scale, where we are looking for units, we're looking for the data, that's the things you know and the things you don't know. So here's the data, the things we know and the things we don't know. The units, of course, we're looking for the answer here at the end, but we're also looking for all the units throughout the problem. The relationships in these cases that help our units cancel out and leave us with our correct final unit, and substitution that we're putting those into our problem in such a way that we end up with the correct answer. So that's how we're asking you to show your work, and you have to do all of that to get 5 points. So here we're looking at a motorcycle engine. We might call this a 750 because it comes out to have 750 centimeters cubed as the displacement of the engine. In 7, we're using a density, some information we know about density to find the mass when we're starting with a certain volume. Now, the one thing that a lot of people had missed here is that that density was given up there. We wouldn't expect you to have that just memorized somehow. So that density is actually used right here, that 10.5 grams of silver is equal to 1 cubic centimeter of silver. So that's where the conversion factor here in this second part of the problem came from, is right up there in the stem of this section. So if we have 15 centimeters cubed of pure silver, that's going to be what we start with. We want our units to cancel, so I'm going to choose to put centimeters of silver on the bottom and grams of silver on the top, because that's the final unit I want. So in my mass to volume ratio here, I have 10.5 grams on the top per 1 centimeter on the bottom. So I just do 15 times 10.5 and I get an answer of 157.5. And rounding that to 3 significant digits, like we see right up here in the problem, 3 significant digits, I get 158 grams of silver.